In this video, we're going to talk about solving a system of equations with a mixture of linear and quadratic, and then two quadratic, this time using our substitution and elimination methods instead of graphing. So when we're dealing with quadratic system of equations, usually substitution is going to be the easiest method because our equations are usually given to us in y equals already. We're not worried about having to get a variable by itself or figure out what we can cancel out. So in this case, both of our equations are given to us in y equals. So that means we are already set up to take what y equals and plug it into the other equation in place of y, so that we end up setting these two equations equal to each other, which will give us 2x plus 6 equals x squared, let's fix that, x squared plus 7x minus 8. Now in this case, because we have a parabola here, a quadratic equation, we have this x squared that we haven't had to deal with before. So instead of just being able to get the x's on the same side and then get x by itself, solving for x, we have to deal with that x squared, which means we're going to have to get everything to the same side of the equation, same side of the equal sign, and we're going to have to use our quadratic solving steps to solve for x, which means we either have to factor it or we'll have to use our quadratic equation. So let's start by getting everything to the same side of the equation. So that means we'll subtract 2x over, and we'll subtract 6 over, so that we're left with x squared, and then 7 minus 2 gives us 5x, and negative 8 minus 6 gives us negative 14. That's going to equal 0 because everything on this side canceled out. Once everything's on the same side, now we're ready to use our quadratic solving steps. So let's always check for factoring. That's going to be our quickest method usually. So we're looking to see if we can find two numbers that multiply to negative 7 or negative 14 and add or subtract to 5. So factors of 14 are 1 and 14 and 7 and 2. 7 and 2 will subtract to give us a positive 5. So that means our two factors will be x plus 7 and x minus 2. And then to solve for x, which is our ultimate goal, we're going to set each of those equal to 0, and then we can get x by itself. So we'll subtract 7, which gives us x equals negative 7 as one answer, and then we'll add 2. That will give us x equals 2 as another answer, or as another value of x, I should clarify. We're still talking about systems of equations here, which means our answers are still ordered pairs. We still need an x and a y for our final answer. So we have two x values right now, which means we need to find two y values. So the way we can do this, we can take those x values and we can plug them back into either one of the original equations to solve for y. So I'm going to keep it easy. Let's plug it into this linear equation so we don't have to worry about squaring anything. So I'm going to start by plugging negative 7 in. So we'll have y equals 2 times negative 7 plus 6. 2 times negative 7 is negative 14 plus 6, which is negative 8. So that means we have the ordered pair negative 7, negative 8 as one answer. And then we'll repeat that process with positive 2. 2 times 2 is 4 plus 6 gives us 10, which means 210 is another answer. So whenever we have, most of the time when we have a quadratic involved in a system of equations, we're going to have two answers. There are times we could only have one if they meet at the vertex, and then there are times that we could have no solution if they don't intersect at all. But the majority of the time we'll probably see that there are two answers coming from a system that includes a quadratic equation. So set those two equations equal to each other, get your values of x, plug those back in to find your values of y, and then you've got your two ordered pairs as your solutions. Let's try another one. Now we have two quadratic equations. that we're using in our system. Same thing as above when we had one quadratic and one linear. We're still going to start by setting them equal to each other and getting everything on the same side of the equal sign. So we're going to take 2x squared plus 2x minus 3 and plug it in for that y. So that we end up with 2x squared plus 2x minus 3 equals 3x squared minus 4x plus 6. Once we have them set equal to each other, we're going to get every term on the same side of the equal sign. It doesn't matter which side you move all those terms to, but I like to keep the squared term positive. So if I want to keep that positive, I know I want to move the 2x squared over to this side because 3 minus 2 is going to give us a positive 1. If we went the other direction, we'd have 2 minus 3, which would give us a negative 1, and that just kind of complicates our factoring process. So we're going to move all of these terms to the right side of the equation. That's going to leave us with x squared minus 6x plus 9 equals 0. Again, we're going to try our factoring steps first. So we're looking for two numbers that multiply to 9 and add or subtract to negative 6. So for our factors of 9, we've got 1 and 9, or we have 3 and 3. And lucky for us, negative 3 minus 3 gives us negative 6. So we'll have x minus 3, x minus 3. And to solve for x, we'll set each of those equal to 0. Now, since those factors happen to be the exact same, there's not really any point to setting them both equal to 0 because we're going to end up with the same answer in the end anyway. So we'll add 3 over and we'll get x equals 3. All right, so we only have one x value this time, which, as I was saying earlier, means that these two parabolas are meeting at their vertices. The vertex for each one is going to be the exact same. We know our answer needs to be an ordered pair, so we have our x. We need to find our y to get that final answer. So we'll take that 3 and we'll plug it back in. Doesn't matter which equation you plug it back into. So I'll just plug it back into the first one. So we'll have y equals 3, and then instead of x, we'll plug in 3 minus 4 times 3 plus 6. So following our PEMDAS steps, we need to square that 3 first. So 3 squared will give us 9. This will give us 9, and then 9 times 3 will give us 27. Negative 4 times 3 is negative 12 plus 6. Then 27 minus 12 gives us 15. 15 plus 6 gives us 21. So that means our answer is 321. That is the only answer this time because they happen to be meeting at their vertices.